You think you know Einstein's energy equation? E equals mc squared. Simple, famous. The most recognized formula on Earth. But nobody tells you the truth about how Einstein understood energy. Nobody tells you about the circular logic in his original 1905 paper. Nobody tells you that he never actually proved it, not once in 40 years of trying. And nobody tells you that a German physicist named Max von Laue delivered the first real proof in 1911, 6 years after Einstein wrote his famous paper. In 1905, Albert Einstein was 26 years old. He worked at the Swiss Patent Office in Bern, evaluating electromagnetic and electromechanical patent applications in a cramped third-floor apartment on Kramgasse 49. From his window, he could see the Zittglogge clock tower. Medieval. Precise. A masterpiece built in 1530 by Caspar Brunner. That clock would change everything. Einstein later told colleagues about his thought experiment. Imagine sitting on a streetcar moving away from that tower at the speed of light. Your watch keeps ticking. But the clock tower? Frozen. Time itself appears to stand still. The mental image cracked open special relativity, and special relativity cracked open energy. Between March and November of 1905, Einstein published 4 papers in Annalen der Physik, a German physics journal printed in Leipzig. The scientific world calls it his annus mirabilis, his miracle year. March 18th. On a heuristic viewpoint concerning the production and transformation of light. June 9th, publication date. This paper proposed that light behaves as discrete particles, photons, with energy determined by frequency. Energy equals h times nu, where h is Planck's constant and nu is frequency. Physicists dismissed it. Max Planck himself apologized for Einstein in 1913, saying Einstein may have gone overboard in his speculations with this light particle idea. Robert Millikan spent 10 years trying to disprove it. He verified Einstein's predictions perfectly in 1916, but still couldn't accept a corpuscular view of light. Even Niels Bohr rejected Einstein's light particle in his 1922 Nobel address. Yet this paper, not relativity, not E equals mc squared, won Einstein the Nobel Prize in Physics in 1921, 16 years after publication. On the motion of small particles suspended in a stationary liquid, as required by the molecular kinetic theory of heat, published July 18th. Brownian motion. Einstein used random particle movement to prove atoms exist. Statistical physics was born. Third paper, June 30th submission. On the electrodynamics of moving bodies. Published September 26th. Special relativity, no mention of ether. Space and time are not absolute. The speed of light is constant in all reference frames. Lorentz transformations fall out naturally. Fourth paper, September submitted, published November 21st. 3 pages, a footnote. Does the inertia of a body depend upon its energy content? Here's where energy breaks open. He wrote, if a body gives off energy, L in the form of radiation, its mass diminishes by L divided by c squared. Not the absolute relationship, just the change. Delta M equals delta E over c squared. He considered a body at rest emitting 2 light pulses in opposite directions. Equal energy. Opposite directions. The momentum cancels. Then he examined the same process from a moving reference frame. He applied the relativity principle, and he concluded that the mass decrease equals the energy loss divided by the speed of light squared. Simple, elegant, wrong. If you value documented physics history and deep-sourced analysis like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from Hans Ohanian's 2008 physics paper, Einstein's E equals mc squared mistakes, published in Studies in History and Philosophy of Modern Physics and the American Journal of Undergraduate Research's January 2016 analysis, Einstein's 1905 analysis of E equals mc squared applied to pion annihilation, both peer-reviewed academic sources that expose the logical flaws in Einstein's original derivation. Now back to the information. Herbert Ives delivered the death blow in 1952. He analyzed Einstein's 1905 paper line by line. His conclusion, the relation E equals mc squared, was not derived by Einstein. Circular reasoning. Einstein assumed what he was supposed to prove. He needed to show that the kinetic energy of an extended system depends on velocity the same way a particle's kinetic energy does. He never proved it, not in 1905, not in 1906 when he returned to the problem, not in 1907 when he tried twice more. Not in an unpublished 1912 attempt, not in 1935, not in his 1946 essay written after World War II. Low-speed approximations that don't work at high velocities. the first complete and general proof of E equals mc squared, valid for any closed system with a time-independent energy-momentum tensor, came from Max von Laue in 1911. The mathematician Felix Klein generalized it further in 1918 for arbitrary time-dependent closed systems, not Einstein. Einstein realized something nobody else saw. Mass and energy are two names for the same thing. Not similar, not related, the same. He wrote in 1946, "The principle of the conservation of mass proved inadequate in the face of the special theory of relativity. Mass isn't conserved. Energy isn't conserved. Mass energy is conserved. They trade places. A gram of mass contains 89 quintillion, 875 quadrillion, 517 trillion, 873 billion, 681,764 joules. That's 9 times 10 to the 16th joules per kilogram. Write it out, 90,000 trillion joules in 1 kilogram. In 1904, a year before his E equals mc squared paper, Curie published in Century magazine, a solid salt of radium develops a quantity of heat such that for each gram of radium contained in the salt, there is an emission of 100 calories per hour. 100 calories. Every hour, indefinitely. Pierre Curie measured it precisely, 590 joules per hour per gram. That's 140 calories. Radium melts its own weight in ice in 1 hour, and it keeps doing it for centuries. Radium's half-life is 1,600 years. After 1,600 years, the heat emission rate is still half the original value. No chemical reaction could explain this. Chemical bonds store a few electron volts per reaction. Radium pours out energy continuously without visible change. He wrote at the end of his November 1905 paper, "It is not impossible that with bodies whose energy content is variable to a high degree, for example, with radium salts, the theory may be successfully put to the test." Radium was broadcasting mass loss, invisible, unmeasurable with 1905 equipment, but real. Einstein concluded that radium must be slowly losing mass as it radiates energy. The amount, too small to measure. But if you could calculate it, the mass loss divided by c squared would equal the energy output. He called the idea amusing and enticing, but admitted, "Whether the Almighty is laughing at it and is leading me up the garden path, that I cannot know." He said direct verification, for the time being, probably lies beyond the realm of possible experience. Plutonium implosion device. 6.15 kilograms of plutonium-239. Conventional explosives arranged in a precise sphere around the core. Kenneth Bainbridge directed the test. J. Robert Oppenheimer chose the code name Trinity, a reference to John Donne's Holy Sonnets. 425 people watched from observation posts 9 to 15.5 kilometers away. They lay on the ground, feet toward the tower, eyes covered. That's 88 terajoules, 15 kilotons from plutonium fission, 6 kilotons from the uranium tamper fissioning. The mushroom cloud rose 50,000 to 70,000 feet. Experts predicted 12,000 feet. They were wrong. About 1.4 kilograms of the 6.15 kilograms of plutonium actually fissioned. The rest, 4.5 kilograms, scattered as fallout across the desert and atmosphere. But here's what matters. Of that 1.4 kilograms of plutonium that fissioned, the resulting lighter elements weighed almost exactly 1 gram less after cooling. 1 gram. Missing. The electromagnetic radiation and kinetic energy, thermal blast energy, carried that missing gram of mass away. E equals mc squared. Proven in fire, in deaths that would follow. Plutonium implosion bomb, nearly 10,000 pounds, built to produce a 22 kiloton blast, equivalent to 22,000 tons of TNT. 6.15 kilograms of plutonium, same as Trinity. About 1 kilogram fissioned, 1 gram of mass converted to energy. The topography of Nagasaki, narrow valleys between mountains, limited destruction to 2.6 square miles. But the weapon proved Einstein's vision. Mass becomes energy. Energy has inertia. They're equivalent. 1 kilogram of plutonium fissioned, 1 gram less mass afterward. Gone. Transformed into radiation and kinetic energy that devastated a city. That's what Einstein understood in 1905 when he looked at radium's endless heat. That's what he couldn't prove mathematically. That's what killed hundreds of thousands. Units of measurement. A choice. Einstein wrote that mass and energy are one and the same. Not metaphorically, literally. A particle at rest has rest energy. Move that particle and its relativistic mass increases. Not because matter is added, because kinetic energy has mass. Add energy to a spring by compressing it, the spring's mass increases. Tiny, unmeasurable for a handspring, but real. The stretched chemical bonds linking atoms store potential energy. That potential energy has mass. Heat a block of iron, its mass increases. The thermal energy of vibrating atoms adds mass to the system, insignificant at room temperature, measurable at high energies. A proton at rest has a mass of 1.67 times 10 to the negative 27 kilograms. Accelerate that proton to 99.9% the speed of light, and its relativistic mass increases by a factor of 22. The Large Hadron Collider accelerates protons to 99.99991% light speed. At that velocity, a proton's relativistic mass is 7,000 times its rest mass. The kinetic energy is enormous, and that kinetic energy has mass. Without E equals mc squared, particle physics doesn't work. Collider calculations fail, predictions collapse. Fission splits it into lighter elements. Krypton 92, 91.926156 atomic mass units. Barium 141, 140.91441 atomic mass units. Add them together with 3 free neutrons, 3 times 1.008665 atomic mass units, and you get 235.877706 atomic mass units. Wait, that's more than we started with. Wrong. The product's way less. The missing mass, about 0.215 atomic mass units per fission event, converts to energy, 200 mega electron volts per fission. Multiply that by Avogadro's number of fissions, and you get the energy that powers cities and kills them. Einstein saw this cascade in his mind before Hiroshima existed, before Oppenheimer's Trinity test, before Enrico Fermi's Chicago Pile 1 went critical on December 2nd, 1942. Einstein wrote to President Franklin Roosevelt on August 2nd, 1939. Leo Szilard drafted it. Einstein signed it. The letter warned that uranium chain reactions could create extremely powerful bombs of a new type. It launched the Manhattan Project. $2 billion, 130,000 workers across 30 sites. Oak Ridge, Tennessee, uranium separation. Hanford, Washington, plutonium production. Los Alamos, New Mexico, bomb design, all built on Einstein's understanding that mass is energy. He later called his letter to Roosevelt the one great mistake in my life. He didn't work on the Manhattan Project. J. Edgar Hoover's FBI deemed him a security risk. Too many socialist connections, too much anti-war activism. So the man whose understanding of energy enabled the atomic bomb was excluded from the project that built it. His equation worked without him. He chaired the Emergency Committee of Atomic Scientists from 1946 to 1948. He lobbied for international control of nuclear weapons. He opposed the hydrogen bomb development. He wrote in 1950, "I do not know with what weapons World War III will be fought, but World War IV will be fought with sticks and stones." His understanding of energy gave humanity godlike power. He spent his last years begging humanity not to use it. Why didn't Einstein prove it correctly? Because he was thinking physically, not mathematically. He imagined light carrying momentum. He pictured bodies recoiling. He saw the world as a theater of interacting energies, not as abstract tensor fields. Mathematicians like von Laue and Klein thought in terms of stress-energy tensors, 4-dimensional geometric objects that encode how energy and momentum flow through spacetime. Von Laue's 1911 proof uses the stress-energy tensor directly. He considers a closed system, no energy enters or leaves, with a time-independent structure. The tensor describes how energy density, momentum density, and stress distribute through space. Conservation laws emerge from the tensor's divergence being zero. This is covariant. It works in any reference frame. From this, von Laue derives E equals mc squared rigorously for any static system. No approximations, no circular logic, full generality. Arbitrary closed systems, time-varying systems, any configuration where energy and momentum don't leak out. The proof still works. E equals mc squared holds. But Einstein never thought this way. He thought in terms of light pulses and momentum conservation and thought experiments with moving trains. Beautiful, intuitive, wrong, or at least not quite right. He grasped the truth. He felt the answer in his bones, but he couldn't build the mathematical scaffold to support it. Henri Poincaré came close in 1900, 5 years before Einstein's paper. Poincaré wrote that electromagnetic energy behaves like a fictitious fluid with mass such that E equals mc squared. He considered momentum conservation in electromagnetic fields. He found that if you require the field's momentum plus any particle's momentum to be conserved together, Poynting's theorem predicts the field acts as if it has mass. But Poincaré never connected this to real bodies. He saw it as a property of electromagnetic fields, not matter itself. Fritz Hausnerl worked the problem in 1904. Austrian physicist, at the time more famous than the obscure patent clerk Einstein. Hausnerl created a thought experiment with heat energy in a moving cavity. He tried to show that radiation confined in a cavity has mass. His first attempt gave 4/3 E over c squared. Wrong. He corrected an algebraic error and got 4/3 E over c squared again. Still wrong by a factor, but he was working the right problem. Heat has inertia. Radiation has mass. Energy and mass are equivalent. Max Planck acknowledged Hasenerl in 1909. That the black body radiation possesses inertia was first pointed out by F. Hasenerl. Every form of energy has mass. Every massive object has rest energy. It's not specific to electromagnetic fields or heat in cavities. It's universal, a principle. Einstein saw that the laws of conservation of energy and conservation of mass are one and the same. That insight, that unification, was his genius. Poincaré saw a mathematical trick. Hasenerl saw radiation. Einstein saw reality. Each vibrational mode has quantized energy. At low temperatures, high-frequency modes can't be excited because the thermal energy is too small to reach the first quantum level. Specific heat drops. Einstein's model predicted this. It matched experiments. Quantum theory explained thermodynamics. But Einstein went further. He realized that the vibrating atom's energy has mass, heat, a solid, and its mass increases by the energy added divided by c squared. Unmeasurably small, but real, testable in principle, true in fact. Energy has mass. Moving mass carries momentum, therefore light carries momentum. Photon momentum equals energy divided by c. Photons hit a mirror. They transfer momentum. The mirror recoils. Radiation pressure. Proven experimentally by Pyotr Lebedev in 1900 and by Ernest Nichols and Gordon Hull in 1901, before Einstein's special relativity. But Einstein's theory explained why. Energy equals mc squared. Light energy divided by c squared gives effective mass. Effective mass times c gives momentum. Momentum transfer pushes the mirror. Quantitative predictions. Perfect agreement. That's 100 million times the energy the Large Hadron Collider reaches. When a cosmic ray proton hits an atmospheric nucleus, it creates a shower of particles, pions, kaons, muons, electrons, positrons, gamma rays, mass created from kinetic energy. A single proton comes in. Dozens of particles come out. Total mass much greater than the original proton. Where did the mass come from? The kinetic energy. E equals mc squared. Energy converts to mass. Particle accelerators do this routinely. Collide a proton and antiproton at high energy. The annihilation energy creates new particles. Bottom quarks, top quarks, W bosons, Z bosons, Higgs bosons. Masses far exceeding the original proton-antiproton mass. All created from kinetic energy. Einstein's equation at work. A patient receives a radiopharmaceutical labeled with a positron-emitting isotope. Fluorine-18 is common, half-life 110 minutes. The isotope decays, emits a positron. The positron encounters an electron in tissue. Electron plus positron, particle plus antiparticle. They annihilate. Total mass converts to energy. 2 gamma-ray photons shoot out in opposite directions. Each photon carries 511 kilo electron volts. That's the rest mass energy of an electron, or positron, divided by c squared. The scanner detects both photons in coincidence, traces the line between them. The annihilation happened somewhere on that line. Millions of these events build an image. Cancer metabolism lights up. Tumors glow. Doctors see inside living tissue without surgery. All because Einstein understood that mass converts to energy, and energy converts to mass. Equivalent to 43 kilotons of TNT, twice the Nagasaki bomb. From 2 grams total, that's E equals mc, squared with 100% efficiency. No fission product waste, no fallout, pure energy. In reality, antimatter production costs trillions of dollars per gram. CERN produces picograms per year, 10 to the negative 12 grams, a speck invisible to the eye. Storing antimatter is nearly impossible. It annihilates on contact with matter. Magnetic traps hold it briefly. Antimatter weapons aren't feasible, but the physics is real. Einstein's equation guarantees it. Gravitational potential energy converts to radiation. Accretion disks around supermassive black holes shine brighter than entire galaxies. Quasars outshine 1 trillion stars, all from matter spiraling inward, heating up, radiating away energy before disappearing forever. The energy radiated? Mass converted via E equals mc squared. A black hole can convert up to 42% of infalling rest mass into radiated energy. Nuclear fusion converts 0.7%. Fission converts 0.1%. Black holes are the most efficient energy converters in the universe. Einstein's equation sets the limit. 3 solar masses missing. Where do they go? Gravitational radiation. In the final fraction of a second, the merger radiated 3 solar masses of energy as gravitational waves. That's 6 times 10 to the 47 joules. More power than all the stars in the observable universe combined, emitted in a fraction of a second. E equals mc squared. 3 solar masses times c squared equals gravitational wave energy. Measured. Confirmed. Einstein's equation written in the fabric of space-time. The sun burns 4 million tons per second. Hydrogen fuses into helium. 4 hydrogen nuclei weigh 4.03 atomic mass units. 1 helium nucleus weighs 4.00 atomic mass units. The difference, 0.03 atomic mass units, converts to energy. About 26 mega-electron volts per fusion reaction. The sun performs 10 to the 38 fusion reactions per second. 10 million times 10 to the 30. 4 million metric tons of mass convert to energy every second. That mass becomes sunlight, infrared, ultraviolet. Visible photons that warm Earth and power photosynthesis and make life possible. All from Einstein's equation. 4 million tons per second sounds like a lot, but the sun has been burning for 4.6 billion years and has consumed only 0.03% of its total mass. It will burn for another 5 billion years before exhausting its hydrogen fuel. E equals mc squared makes stars possible. Protons capture electrons to become neutrons. A neutron star forms 10 to 20 kilometers across, weighing 1.4 to 2 solar masses. Density 400 trillion times water. 1 teaspoon weighs 1 billion tons. The gravitational binding energy released 10 to the 46 joules. 99% escapes as neutrinos. 1% blows the outer layers into space at 30,000 kilometers per second. The explosion brightness rivals an entire galaxy. All visible matter in the universe came from supernovae: carbon, nitrogen, oxygen, iron, gold, uranium, all forged in stellar furnaces and scattered by supernova explosions. E equals mc squared powers the cosmic furnaces. If you're still following this deep analysis of Einstein's energy concept, subscribe to this channel now. This kind of detailed, source-backed physics history takes serious research to deliver. Comment from which city you're watching this from. This script relies on verified sources, including the 2005 NOVA article, The Theory Behind the Equation, published by PBS, and the April 25th, 2009 Studies in History and Philosophy of Science paper, Did Einstein Prove E equals mc squared? By Hans Ohanian, a historian of physics who spent years combing through Einstein's papers, correspondence, and unpublished work to document exactly how the equation was derived and why Einstein's proofs failed. Now back to the information. Einstein's field equations of general relativity encode E equals mc squared at a deeper level. The Einstein field equations, g mu nu equals 8 pig over c to the 4th times t mu nu. G mu nu is the Einstein tensor, describes space-time curvature. T mu nu is the stress energy tensor, describes matter and energy distribution. The equations say mass energy tells space-time how to curve. Curved space-time tells mass energy how to move. Mass and energy are equivalent here. They curve space-time identically. A photon, massless but carrying energy, curves space-time. It bends space-time geometry just like a massive particle would. Not as much. A photon's energy is small. But the principle holds. Energy gravitates. Mass gravitates. They're the same. General relativity predicts that clocks run faster in weaker gravitational fields. GPS satellites orbit 20,000 kilometers up. Earth's gravitational field is weaker there than on the surface. Satellite clocks tick 45 microseconds per day, faster than ground clocks. Special relativity predicts that moving clocks run slower. Satellites move at 14,000 kilometers per hour. Their clocks tick 7 microseconds per day, slower than ground clocks. Net effect, 38 microseconds per day faster. If GPS didn't correct for this, position errors would accumulate at 10 kilometers per day. GPS relies on Einstein's relativity, both special and general, and on E equals mc squared underlying both theories. Your phone's map app proves Einstein right every time you check your location. The cosmic microwave background encodes E equals mc squared across the universe. 380,000 years after the Big Bang, the universe cooled enough for electrons and protons to combine into neutral hydrogen. Before this, photons scattered constantly off free electrons. The universe was opaque. After recombination, photons streamed freely. That radiation, stretched by cosmic expansion to microwave wavelengths, still fills the universe. Temperature, 2.725 Kelvin. Every cubic centimeter contains 400 microwave photons. They carry energy. Energy has mass equivalence. The photon energy density, 4.2 times 10 to the negative 14 joules per cubic meter. That equals a mass density of 4.6 times 10 to the negative 31 kilograms per cubic meter. Tiny. But spread across the observable universe, 10 to the 80 cubic meters, it adds up to 10 to the 50 kilograms. That's 30 million solar masses worth of energy in cosmic microwave background photons. E equals mc squared, accounting for the energy content of empty space. Dark energy dominates the universe's energy budget, 68%. Its density, 6 times 10 to the negative 10 joules per cubic meter. Equivalent mass density, 6.7 times 10 to the negative 27 kilograms per cubic meter. Dark energy doesn't clump. It fills space uniformly. It drives cosmic acceleration. Galaxies recede faster and faster. Type Ia supernovae at high redshift appear dimmer than expected. Space itself expands at an accelerating rate. The cosmological constant, lambda, Einstein's greatest blunder. He introduced it in 1917 to create a static universe. Then Edwin Hubble discovered cosmic expansion in 1929. Einstein called lambda his biggest mistake, but observations in 1998 showed acceleration. Lambda came back. Dark energy is real. Its energy density converts to mass density via E equals mc squared. That mass density determines spacetime curvature via Einstein's field equations. The universe's fate depends on it. Planck mass, square root of h bar times c divided by g, about 22 micrograms, tiny by everyday standards, enormous by particle physics standards. 22 micrograms is 10 to the 19 giga-electron volts. The Large Hadron Collider reaches 10 to the 4 giga-electron volts. The Planck energy, Planck mass times c squared, is where quantum gravity becomes important. Black holes smaller than the Planck mass evaporate instantly via Hawking radiation. Quantum fluctuations at the Planck scale create virtual black holes that pop in and out of existence. Spacetime itself becomes foamy, uncertain. E equals mc squared connects this quantum foam to energy and mass scales. At the Planck energy, you can't separate gravity from quantum mechanics. Einstein's equation bridges both domains. String theory proposes that fundamental particles aren't points, but tiny vibrating strings. Different vibration modes correspond to different particles: photon, electron, quark, graviton. All the same object vibrating differently. String tension, 10 to the 14 kilograms per meter. Strings are 10 to the negative 35 meters long. The string mass, string tension times length divided by c squared equals 10 to the negative 35 kilograms. That's near the Planck mass. String vibrations carry energy. Energy has mass via E equals mc squared. Different string vibrations have different masses. That's why particles have different masses. Electron, 9 times 10 to the negative 31 kilograms. Up quark, 3 times 10 to the negative 30 kilograms. Top quark, 3 times 10 to the negative 25 kilograms. All from string vibration energy. E equals mc squared at the Planck scale. He can't know that von Laue will have to fix his proof. He can't know that his equation will enable weapons that kill hundreds of thousands. He can't know that GPS, PET scans, particle accelerators, nuclear power, and cosmology will all depend on his insight. He writes, "The mass of a body is a measure of its energy content." Simple sentence, universe-changing implications. Should we say mass increases with velocity, or that momentum increases faster than classically expected? In modern physics, mass means rest mass, invariant mass. Relativistic energy includes both rest mass energy and kinetic energy. The controversy is semantic. The equation works either way. E equals mc squared holds in any interpretation. A dollar can be cents, or paper or bank account digits. It's still a dollar. Mass can be energy, or energy can be mass. It's still mass energy. That's the genius. Not the mathematical proof, the conceptual leap. In 2021, researchers reanalyzed Trinity test data using modern statistical methods. Published in Nuclear Technology. New yield estimate, 24.8 kilotons, plus or minus 2 kilotons. That's 18% higher than the original 21 kiloton estimate. The mass converted to energy, not 1 gram, but 1.18 grams. Slightly more mass than previously calculated. The equation still holds. E equals mc squared. 1.18 grams times 9 times 10 to the 16th joules per kilogram equals 106 terajoules. 24.8 kilotons TNT equivalent. Perfect agreement. The equation withstands scrutiny. 80 years later, archaeologists of the atomic age dig through fallout data and find Einstein's equation etched in plutonium decay and blast wave propagation. The way Einstein understood energy was more genius than most imagine because he understood it wrong in the details but right in the essence. He never proved it rigorously. Max von Laue did that. But he grasped the deep truth. Mass and energy are the same thing in different forms. That insight, that unification, transformed physics, enabled technology, unleashed horrors, powers cities, burns in every star, curves space-time around every galaxy, whispers in cosmic microwave photons, hides in dark energy, awaits discovery in quantum gravity. Einstein died April 18, 1955, at Princeton Hospital, age 76. He refused surgery for an abdominal aortic aneurysm. He told his doctors, "I want to go when I want. It is tasteless to prolong life artificially. I have done my share. It is time to go. I will do it elegantly." His last words were in German. The nurse didn't speak German. They're lost. But his equation remains. 3 symbols. E equals mc squared, carved into reality, proven in stars, measured in bombs, embedded in the universe's fundamental structure. Einstein understood energy as no one before him had. Not perfectly, not completely, but deeply enough to change everything. Imagining streetcars racing light beams, seeing past Newton's absolute time and Maxwell's ether. Realizing that mass is frozen energy and energy is liberated mass. One thing. One conserved quantity. One equation that explains fusion and fission and cosmic rays and black holes and the cosmic microwave background and GPS and PET scans and why the sun shines and why supernovae explode and why the universe expands and why matter exists at all. E equals mc squared. Not his equation by proof. His equation by insight. Einstein later called Besso his best-sounding board for ideas. That day in May, Einstein explained his decade-long struggle. Newtonian mechanics versus Maxwell's equations. 2 pillars of physics. Incompatible. One had to be wrong. The conversation lasted hours. Einstein went over the paradox of racing a light beam again and again. Then, suddenly, the next day, it hit him. The key to the entire problem. He understood that time isn't absolute. Simultaneity depends on your reference frame. 2 events that appear simultaneous in one frame occur at different times in another frame. That insight cracked special relativity wide open. Within 6 weeks, he wrote the paper on the electrodynamics of moving bodies. No citations, no references, just pure thought. The paper's introduction states the problem clearly. Maxwell's electrodynamics leads to asymmetries that don't attach to phenomena. Consider a magnet and a conductor. Move the magnet past the conductor, and an electric current appears in the conductor. Maxwell's equations explain this by saying the moving magnet creates a changing magnetic field, which induces an electric field which drives the current. Now move the conductor past the magnet. Current appears again. Same current. But Maxwell's equations explain it differently this time. The moving conductor's electrons experience a magnetic force which drives the current. 2 different explanations for the same phenomenon. Einstein found this unsatisfying. The physics should be the same regardless of which object moves. The asymmetry exists only in the theory, not in nature. Einstein's solution. Adopt 2 postulates. First, the principle of relativity. Physical laws work the same in all inertial reference frames. No experiment can tell you if you're moving at constant velocity or at rest. Second, light travels at constant speed c in all inertial frames, always. Regardless of the source's motion or the observer's motion, these 2 postulates seem contradictory. If I shine a flashlight while running, shouldn't the light move faster in the direction I'm running? Newtonian mechanics says yes. Einstein says no. The speed of light is always c, no matter what. From these postulates, everything follows. Time dilation, length contraction, relativity of simultaneity. The Lorentz transformations emerge as mathematical consequences. Moving clocks tick slower. Moving rulers shrink along the direction of motion. Events simultaneous in one frame aren't simultaneous in another. All measured, all confirmed. Moons, created by cosmic rays in the upper atmosphere, shouldn't reach Earth's surface. Their half-life is 2 microseconds. At 98% light speed, they travel only 600 meters before decaying. The atmosphere is 15 kilometers thick. They shouldn't make it, but they do. Why? Time dilation. In the muon's reference frame, time passes normally, but Earth's clocks tick slow. The muon's lifetime, measured by Earth clocks, stretches to 15 microseconds. Plenty of time to reach the ground. E equals mc squared hides in this time dilation. Classical physics says kinetic energy equals 1/2 mass times velocity squared. At low speeds, this works. But as velocity approaches light speed, classical physics breaks. You pump more and more energy into the proton. Its velocity barely increases. Where does the energy go? Into relativistic mass. The proton gets heavier. Its inertia increases. Pushing it faster becomes harder and harder. As velocity approaches c, the relativistic mass approaches infinity. You'd need infinite energy to reach light speed. Impossible. The speed of light is a cosmic speed limit. Not because of engineering limitations, because of the structure of space-time itself. But a massless particle must move at c. It can't move slower. There's no rest frame for a photon. Photons experience no time. From a photon's perspective, emitted and absorbed occur simultaneously. It crosses the universe in an instant. To us, 13.8 billion light years takes 13.8 billion years. To the photon, zero time. This is what Einstein saw. Light's constant speed isn't an arbitrary fact. It's a consequence of space-time geometry. Mass and energy determine what speeds are possible. Now fold E equals mc squared into this picture. Rest mass energy plus kinetic energy equals total energy. Write it precisely. Now E squared equals p squared c squared plus m0 squared c to the fourth. E is total energy. P is momentum. m0 is rest mass. For a particle at rest, p equals 0. The equation reduces to E equals m0 c squared, Einstein's famous formula. But for a moving particle, momentum contributes. Total energy increases. Relativistic mass increases. At the speed of light, if that were possible for massive particles, momentum becomes infinite, energy becomes infinite, mass becomes infinite. The equation breaks. That's why massive particles can't reach c. The equation forbids it.